This is 4.1 rational functions. Rational functions is a function it's a function that has a fraction of polynomials. So we just got done talking about graphing polynomials in the last section. We talked about finding zeros. Now, what happens if we have a polynomial divided by another polynomial? Well, one thing we have to consider is that x, on the denominator, you cannot have 0 on the bottom. You cannot have 0 on the bottom. You got to keep that in mind because it's undefined. Well, what happens just on this simple function, 1 over x? Well, notice if I started plugging in numbers, like if I plug in 1, well, that's just 1 over 1, which is 1. So if I graph the function, or the point 1, 1. Well, what happens if I graph x is 2? Well, 1 over 2 would be 1/2. So at 2, it's at 1/2. How about 3? Well, that's 1/3. That's 1/4. So notice it's getting lower. So even if I got all the way to 10, it'd be 1/10. All the way to 10. So this is going to get closer and closer and closer, but it's, even if I put 1,000 in, it's going to be 1 over 1,000. It's always actually going to be above this line. It's actually going to be above that line right there. No matter how big I go, even if I go to 1,000, it's going to be 1 over 1,000. So it's always going to be above that line. But notice what happens as I get closer. Like, in other words, what happens if I plug 1/2 in? Like, if I considered what happens when I get closer to 0, because I cannot have 0 in there. But if I put a 1/2 in there, so 1 divided by 1/2 is 2. So at 1/2, it's up here at 2. Well, what if I put in 1/3, even a smaller fraction? Well, that's going to give us 3. What if I put a smaller fraction in? That's going to give us 4. What if I put 1/10 in, like really close to 0? That's going to give me 10. So as I get closer here, as I get closer and closer to 0, this is getting closer and closer, gets higher and higher up. But even if I put like really tiny 1 over 1,000, like that's very close to 0, but that's just going to give us a very high number. So it's going to get closer and closer. So notice as I start to graph this function, it's going to literally look like this. So I want you to consider normally we consider 1, 2, 3. We just put the normal nice numbers into the XY chart. But I want you to consider what happens when I get closer to 0. In this case, because I can't have 0 on the bottom, so what happens when I get closer to that number? Well, look at the other side of the XY chart. So again, if the other side of 0. So if I made another XY chart and just looked at -1, -2, -3, and closer like -1/2, -1/3, or -1/4. I mean, consider the same type of numbers that you did here, but consider what's happening on the negative side. So if I plug -1 in, I'm going to get 1 over -1, which is -1, so 1, -1. And then if I plug -2 in, I'm going to get -1/2. And then if I plug -3 in, I'm going to get -1/3. And if I plug in -1/2, I'm going to get -2. So notice this graph on this side is going to look like this. And again, it's going to get closer and closer to 0 right here, never touch it. And this is going to get bigger and bigger in a negative way. But it will never, ever reach this line right here and the red line. It will never reach that. Now, if you graph this, just want to let you know, if you graph 1 divided by x, and you graph it, you're going to see this graph right here, and you're going to see that it's the same thing that I have. Now the graph looks, I want to be very clear on it, it looks like it touches the line. Okay, it looks like it touches it. You got to be very careful and realize that it actually cannot touch that line. It can never get to that 0 mark, okay? Because, and I showed you on the XY charts, it's always going to be above that. It's always going to get closer and closer. And it's all based on this, all based on that. You cannot have 0 on the bottom of a fraction. Well, what we just now talked about was an asymptote. An asymptote is a line that cannot be reached. So notice on earlier there was two asymptotes. There was the green line, the vertical asymptote, and then the red line, that's a horizontal asymptote, that the function will never reach those points. It will never get to those points. It just gets very close to it, and those are called asymptotes. So it's like an invisible line, but the function will never get there. So notice this function right here. Let's consider that function. Well, if you just look at what happens, notice you cannot, the first thing you should notice, you cannot have 3. X cannot equal 3 on the bottom. Because if I did, that would give me 1 over 0, which is undefined. So that's why I know there is a asymptote right there at x equals 3. That is the equation of the vertical asymptote. And x cannot equal that. Then I want you to consider all the numbers that are away from that. So at 4, at 5, at 6, what's happening to that function? At 3.5, at 3 1/4, what is happening to that function? And then I want you to consider, look at the XY chart on the numbers that are less than 3. So at 2, at 1, at 0, at -1. And how about like at 2.5? So consider all of those numbers and what's actually taking place. And you can use your calculator, that's fine, but I mean, I want you to, without a calculator, just plug in 1 or 2 numbers on the right side, plug in 1 or 2 or 3 numbers on the left side, and look at how the graph is happening. But the first thing you should notice is what the vertical asymptote is, and x cannot equal 3, and that tells you literally what it is. So again, if you wanted to use your calculator, you can, but 1 over x minus 3, and if you graph that, you're going to see the exact same thing. Now again, the graph does not show a vertical asymptote, but which, by the way, it can. Your calculator can show that, but it looks kind of confusing. I would recommend not showing the asymptote. You just notice that it cannot equal 3. And then again, your calculator looks like it hits the 0 line. It does not. It does not do that. So it's going to look like this. Get closer and closer and closer. It will never reach that line. Okay, so don't actually cross over that line. And again, it gets higher and higher and higher, but it never reaches that. Okay, and then the same thing here. It gets lower and lower and lower and lower, but never reaches that asymptote. It gets closer and closer and closer, but never reaches that line. Okay, so there's a horizontal asymptote and a vertical asymptote. The horizontal is this guy right here, right on the line. Right, so again, look at your asymptote, figure out where it cannot equal, and that's your vertical asymptote. Now, let's look at, how do you know where the asymptote is? Well, because this polynomial could be anything, okay? You guys know polynomials can be really big, x to the 20th power, and x to the 13th power. So it could be any type of polynomial. So how do you find a vertical asymptote, and how do you find a horizontal asymptote? Well, a vertical asymptote, I've already said, is where it can, you got to find out where it can't be 0 on the denominator. Okay, it can't be 0 on the denominator. Just say that 1,000 times. Make sure you look at the denominator. You cannot have 0 on the bottom. You got to be very clear on that. You cannot have 0 on the bottom. That's your vertical asymptote. Okay, so even if I had something like x minus 3 and x plus 4 on the bottom. Okay, that means x cannot equal 3 and x cannot equal -4. So notice there are 2 vertical asymptotes on that. The x cannot equal that. So that's something you have to definitely know. There could be 2 vertical asymptotes. There could be 3 vertical asymptotes. There could be 5 vertical asymptotes. You have to look at the bottom, basically factor it if you can, and then find out, which you should be able to, because we covered that in the last chapter. You can factor anything. So find out what the vertical asymptotes are. And then how about the horizontal asymptotes? Well, the horizontal asymptotes, what you're going to basically do is look at the high exponents. Only the high exponents, because it's going to give you a big clue. So notice it says if n is, highlighter, if n is less than m. So notice the exponent if n is less than m. So in other words, if the bigger denominator, the bigger exponent is in the bottom, like 1 over x. or 1 over x squared, or something like that, or even x over x cubed. I mean, the bigger one is on the bottom, okay? Then the horizontal asymptote is at y equals 0. That's exactly what we just graphed on the previous. You know, there's a horizontal asymptote because the bigger exponent is on the bottom, okay? The horizontal asymptote is at 0. Now, if n equals m, so it's possible to have something like x cubed plus blank, blank, blank over x cubed plus blank, 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 okay? Now, if they equal each other, then you take the coefficients. So if this is, let's say, 3 over 2, okay? So if it's that way, then the horizontal asymptote is literally, you know, y equals 3 over 2. You know, if the exponents equal one another, then it's just the coefficients divided by one another. And if n equals m, so if or n is greater than m, then there is no horizontal asymptote. So in other words, if I had x cubed over x squared, something like that, the bigger one's up top, then there is no horizontal. So let's look at a problem here. So here I have a problem. Notice I have this right here. First thing I would notice, very first thing I would notice, x cannot equal -2. And that tells you right off the bat that you have a vertical asymptote at x equals -2. Also, if you notice the x to the first and the x to the first are the same, that means that y equals 3 divided by 1, or just 3. So you have a horizontal asymptote at 3. So notice there, these are the two asymptotes, a horizontal and a vertical asymptote. Now, if you plug this in, you know, all you're going to do, I mean, you're welcome to use a calculator if you want, but even without a calculator, just make an XY chart away from this. So literally start plugging in like -1, 0, 1, -3, -4. So whatever the vertical asymptote is, that's what numbers you're looking at. All right, so, but if you want to use your calculator, 3x plus 5, and then x plus 2, and then you can just simply push graph, and you can see that the function is going to look like this. But again, without a calculator, you can just simply plug in numbers that are based off of the vertical asymptote. Let's look at another one. So, consider this one. This is very similar. Notice x cannot, first thing you should notice, x cannot equal 1. Okay? That tells me that there's a vertical asymptote at 1. Also, this is going to be, if you notice the denominator, if you multiply that out, and then you have the top, notice the exponents are the same again. So that means you're going to take a divided by b. So I know there's a horizontal asymptote at 2. And then, so I know x cannot equal 1. That's a vertical asymptote. And then y cannot equal 2. And then you can just plug that into your calculator again and find out the function. So here I have it graphed. So don't always assume that it's going to be diagonal, the graph. So here you have, you know, a function looking like this and a function looking like this. So again, without a calculator, just make an XY chart. X equals 1. That's the vertical asymptote. So think of 2, 3, 4. Think of 0, -1, -2. Numbers away from the vertical asymptote. That's what you really want to look at. The other thing I want you to know how to do is domain and range. We've talked about domain and range multiple times. So the domain of this function, again, a domain is your x line. So it could be any number except 1. So it's -infinity all the way to 1, and then 1 all the way to infinity. The range could be any number except it can't be 2. So -infinity all the way to 2, and then 2 all the way to infinity. So that's how you graph rational functions, and considering asymptotes and using the calculator is very handy, but you don't need to. You can always just make an XY chart as long as you recognize your x and your y, your horizontal and your vertical asymptotes.